Uh, so we will be discussing today the NFVI design architecture of Globe Telecom. Liberius is an experienced core network engineer and NFVI design architect with a history of accomplishments in the telecommunications industry. He is skilled in Python, that's a programming language, Raspberry Pi, public speaking, and virtualization. He's also an IT professional with a Bachelor of Science in Computer Engineering from FEU Institute of Technology. Uh, Everyone, please welcome Liberius Enio Taru. Back to you, Liberius.
Hello, everyone. Good morning. I hope my audio is clear here, no? Okay, wait. Let me just turn on the camera so that I can give a video good morning from here. Hi. Okay, so um, good morning again. So the topic that I'll be giving out for this morning is will actually focus more on what was introduced a while ago. This is about open flow, SDN, which is software defined networking, and NFV, which is network functions virtualization. These are actually technologies that are more applicable and it's more visible in fact in the core domain of our wireless and actually in telecommunications network in general. So let me share my screen. Now, NFV in itself, it actually consists of a myriad of technologies, one of which is what's called virtualization. And the topics and the scope impact of this 1 hour session that I'll be giving out. I've named this one is actually NFV Essentials, primarily because once, hopefully by the end of the session, you would already have at least a high level understanding on some key terms and terminologies that would be encountered whenever we uh, talk about NFV in general. No? We'll be talking here also not just virtualization itself, but also cloud related and even IT related terminologies such as data centers, cloud computing, and there's also what's called XaaS or anything as a service, as well as, of course, I'll be briefly touching on um, open flow, open daylight. These are actually platforms. These are protocols, which I'll also be discussing, and how they also intermingle with NFV. So just to set you the expectations as well as the perception of what NFV really is. This is actually a mix of different technologies working hand in hand for us to provide a different approach on how we can deploy our network functions or network elements. Okay, so learning objective for you guys is I just have here three basic objectives. So first one, I'll briefly describe to you what is NFV if we're going to compare it to a typical appliance-based deployment in our telcos. I'll also describe here some key terms and terminologies that's related to IT virtualization in SDN. So SDN, you can actually treat this as a separate technology on its own. But I'll also discuss here briefly how is it interplaying or interworking with NFV. In fact, SDN is a technology that already came prior to network functions virtualization, but we would see here later on that although it can be treated as a separate technology on its own, it can also be used as a supporting technology to NFV. And or already discussing network functions virtualization, we should might as well discuss here the architecture that it follows. So I won't go dive much on the architecture itself, but just briefly discuss to you what are the different functions and parts inside it. Okay, so here's the topics that I'll be covering. I'll give you a general overview of what NFV is, as well as I've mentioned, key terms and terminologies related to NFV. I'll discuss here what is virtualization, what are virtual machines, as well as the key component for virtualization called the hypervisor. I'll also discuss here cloud computing, software-defined networking, anything as a service, as well as what I personally call the OpenX terminology. So what is open flow, open stack, open data? You'll notice now that once we dive into NFV, we're not just talking here of telecommunications anymore, right? Because primarily we are already incorporating here um, technologies that we originally see in IT applied in a telco use case. I also discuss here, of course, the standard implemented by NFV on how we can deploy an NFV use case. And finally, show to you the relationship and interworking of SDN and NFV. And in the bigger picture, where are we right now in the industry, in terms of its use cases? Okay. So I'll also occasionally check also the Q&A portion in chat. If there would be questions, I'll occasionally drop by. Okay. So let's start. Now, network functions virtualization might sound like at first a quite intimidating term when it on its own, right? So for us to have a better perception of it, let's try to compare it with a typical deployment of a network element. So let's talk here telco a bit. No? Whenever we deploy new network elements or network functions, they normally come in what's called appliance-based deployment in NFT terminologies. No? The reason why it's called appliance-based, it's primarily on how the function is connected into our network. In other words, the network elements themselves are normally associated to a specific hardware. Most of the time, it's vendor proprietary. It would come with its own operating system or software, with again its own licenses. And from there, we can already deploy the function that is intended to be set up and cater in order to cater a specific service in our network. So in my example here, I give to you two example network functions or network elements, a firewall or a CPE. Back then, whenever we want to deploy a firewall service, we have to purchase the entire functionality from the hardware, software, even licenses from only one specific vendor, okay, or one specific OEM or supplier. Okay, if there's a certain feature that we need, then and it's currently not existing in, say, a firewall that we already have in our network, no? You have to purchase another one from another vendor. No? So this has already been the conventional way for us to deploy network elements in general. No? The problem, or not necessarily the problem, the challenge that we experience here is that we experience what's called a vendor lockup. In other words, if there is a certain feature that we want to deploy in the network, and it would only be provided by a specific vendor, we're actually forced to buy everything from that vendor, right? When we transition to network functions virtualization, this gives operators and telcos a bit of a headspace and a bit of leg room. Why is it? You'll notice in terms of the how we deploy now network functions, it can now have what's called a common NFT platform or infrastructure. Okay? And instead of using or instead of outright deploying the network elements as services, we first have to deploy them as what's called virtual machines. Okay, so this is where the virtualization aspect of NFV will be coming in. We're now going to utilize one of the technologies called virtualization. Now, why do we even need to deploy virtualization in the first place? Because right now, in our in our IT industry, they have used virtualization to maximize the hardware, the servers that they normally deploy whenever they want to put up, say, a certain web server, a certain database. No? They've already encountered the same experience or same challenge that telcos that are already experiencing fairly recently. But of course, for IT-based use cases. So example, if they want to deploy a web server back then, no, they have to put up a separate server for our catering web server. If they want to have email services in their industry or in their company, for example, they have to install a separate server for mail. Okay? If they want to have a database, they have to purchase again a separate server for the database application. So you'll notice the similarities there that we have. So what they did was in IT they developed virtualization in such a way that yes, I still have my email, I still have my web server, I still have my database. But instead of seeing three separate servers catering three separate IT applications, I can just have one server, and inside of it, I can already have three working applications. Now, take that deployment or paradigm and place it in a telco environment, and you essentially have an wherein instead of hosting database applications, web servers, the email, you already have telco grade network elements such as GGW for 4G. We also have HSS for 2G and even 5G. So among others. Now, um, the challenge again here lies wherein the deployment, because these are telco grade, of course, it would be catering to a larger number of end users, right? So for us to better manage the expected density of servers that would be deployed in data centers, we need a way to manage everything through a common needs. This is where another component of NFV would come in, called management and network orchestration, or in some books, it's just called management and orchestration, MANO for short. No? So if we're now going to compare the features of what NFV has compared to an appliance-specific deployment, no? It is already first off using centralized commercial off-the-shelf hardware, meaning that through the use of existing servers from existing OEMs such as Dell, HP, to name a few, no? We can already get those hardware, install applications that are also decoupled. In other words, it's not tied up to a specific hardware. Install them immediately as a typical application would come in. And if there's a need for us to do expansion on these network elements, then we can already we can already perform what's called scaling, wherein because these are virtual machines, it's just a matter of for us to just spin up another VM instance, and we immediately have another network element on the fly. Okay? And another advantage of NFV here is that because we already have the manual component, there's a means for us to monitor everything centered. Unlike in an appliance-based deployment, wherein if a certain network element has its own monitoring system, you have to log into that system. And then if it has another separate management system, you also have to log in. In NFV, we are already simplifying the needs of how we monitor our network services. Okay. Now, I'll now discuss here some key terms and terminologies. So you'll notice that I've already introduced here virtualization, virtual machines. Okay, I also introduced you what are data centers, network functions. In the next few slides, I'll be further discussing these. So, I've actually categorized these terminologies through four different categories. So first off, I'll discuss what are the terms that you might encounter when we talk about virtualization. So first off, what is virtualization? First things first, virtualization, this is different from virtual reality or in the common term in fairly recent discussions, the metaverse. This is not a virtual world. Virtualization is a technology for us to create what's called virtual resources. And when we say virtual resources, think of it like a sort of a small object within the larger system. Okay? Virtualization is normally applied in IT computing. In other words, it's applied in uh, desktops, laptops, and in larger scales, servers. Okay? It's a technology that allows us to run multiple independent systems on the same physical hardware. As you would see here in the diagram, a simplified version of it, we only have one piece of hardware, but through virtualization, it's actually possible for us to have smaller deployments of computers inside a large physical computer. So think of virtualization as sort of like a means for us to quote unquote partition an existing hardware. Okay. Now, for us to do virtualization, we need a piece of software to create the byproduct or the small partitions. Okay. And that application or software is called the hypervisor. Now, in some books, this is also called the virtual machine monitor. This is actually the software responsible for creating the small pieces of system or small chunks of system that we have in our physical machine. Okay? And the technical term for that small chunks or small pieces inside the physical machine is called virtual machines or VMs. Now I'll go back again to hypervisor. A hypervisor or virtual machine monitor, this is a piece of computer software, firmware, or even hardware that creates and runs virtual machines. It's actually responsible for creating small partitions from the underlying physical hardware and generate a small virtual portion of it. So remember that your computer, it has physical resources such as a processor. It also has memory or RAM. It also has storage. Okay? And it also has network connectivity. You can only install one operating system in your computer. In other words, if I have here an example, if I have here Windows, I cannot simultaneously install Windows and say Linux in the same platform and run them at the same time. Okay? When we deploy virtual machines, the byproduct of virtualization, we can still have one large machine. It can still have its own operating system, Windows, for instance. But on top of that, we can create smaller computers, of it as smaller computers, wherein they also have their own memory, their own storage, their own core or processor, and they run independently from the physical host machine. Okay? So in a typical virtualization scenario, you can have Windows as hardware, but instead of it, you can have 2 or 3 Linux operating systems running simultaneously. This is where now it is possible for us to simultaneously run these different systems within just one physical device. Okay, so we have virtualization, virtual machines, and finally the hypervisor. Okay, now where does now the concept of IT Let's first kick off here in virtualization. Virtualization is normally applied normally in just one physical machine. In other words, I just have uh, one host or one server, and inside of it, I can already deploy 4 or 5, 2 or 3 virtual systems inside of it. But again, it's constrained to one physical. Let's now go into cloud computing. We cannot discuss actually NFV without also tackling cloud. In virtualization, we're just limited to just one machine. If we now try to implement this on a bigger scale, this is or virtualization can support cloud computing. Um, Back then, no, whenever we say cloud computing, um, the first thing that comes into mind is that this is a technology. Cloud. Uh, it just means that there's a new application that would come. So yes, these are actually all true. But if we're going to look at it from a textbook definition, what is cloud? What function does it serve? Actually, cloud enables on-demand network access to a shared pool of configurable compute resources. Think of cloud computing as a means of, or as an approach on how we can share resources to a large number of people. Yes, you can say that cloud is a new technology. Yes, cloud also requires a software on its own. But in its essence, no, cloud computing is actually an approach, a paradigm in how we can share resources. And what specific resources are we referring to here? These are actually IT-based resources back then, such as servers, storage applications, network connectivity. In some scenarios, there are also offerings of security services. Okay? And it also shares some characteristics. No? For a system to be considered to be a cloud, no? um, it has traits. No? Actually, the 5 basic traits of a system to be a cloud are here below. If you have a system that is an on-demand or it offers on-demand self-service, in other words, the end user can come into your system. Um, they have the capability to provision their own resources on the fly. It's on demand. Then you have on-demand self-service. Ubiquitous network access. This just means that even if, say, I am here in the Philippines and I want to get resources outside of my country, say, I want to get resources from the US, or I want to get compute resources, say, from Canada or Indonesia, I can easily do so through a user internet. I just log in via the internet. That's meaning ubiquitous network access. I can easily access the system wherever I am, provided, of course, that I have network connectivity. Okay? Resource pooling, it should be location independent and homogeneous. In other words, me as an end user, I technically don't have to care if, say, I want a server or I want a server that has 4 cores, for instance, with 128 gigabytes of memory, and I ask my cloud provider for those requirements. I essentially don't have to care on whether the server that you would provide me is Dell or HP or even Fujitsu at that matter, no, among others. I just need these resources. It's up to you as the cloud provider to give me that resources. And once I already have these resources, no, if there are upgrades that you have to perform on your upgrade, it's your role as the cloud provider to ensure that the resources that I have are up to date, okay, and notify me if there are any issues or errors encountered whenever I am using my resources. Okay? So that's resource pooling. Rapid elasticity. If there's a need for the cloud provider to immediately increase or decrease the resources that it has on its cloud. It can easily do so through the use of tools or management platforms that it has in its system. And finally, measured service, because cloud computing is offering services to its end users, is a way to measure out how much of a specific service it has already given, as well as to monitor other technical parameters normally found under the hood, such as utilization, performance, drop rates, among others. If you have all of these five characteristics in your system, you essentially have technically a cloud. Normally nowadays, cloud platforms, these are they come in already software applications. Okay. Some of them can be proprietary, some of them are even open source. For now, I'll go on to the next one, which is SDN, software defined. SDN, before it was used in telco applications, it was intended to be used again from IT use cases. In technical definition, SDN, or software defined network, decouples the network control and forwarding functions of your network devices. Now, if you are not really much into IP networking, this may sound general, but let's rephrase the term. In networking, IP networking, to be specific, wherein you already utilize switches and routers. If you want to configure a route in your network, you have to log in to the switch, configure its routing table or switching table, okay, and rely on protocols to have that routing table spread across all of your network elements or network devices. And then you repeat the same process X number of times depending on the number of networking switches that you have. Okay. The configuration of routing tables, okay, the setting up of the routes in your network devices. This is what's called the network control. My apologies. This is network control. So you are essentially configuring individual the devices. Okay? If there's a fault in one of the routes that you have in your network, again, best effort, you would rely on the configured protocols to configure the next best route. While you, as the engineer of the network, you're asked to manually troubleshoot the switches, and heck, even go through all of them in worst scenarios and pinpoint where the fault lies. There are a lot of manual tasks that we perform. In SDN, again, we are redesigning how we implement networking, IP networking. Okay. Instead of just having switches and routers in your network, similar to virtualization, we also deploy another component for us to have SDN. And that component is what's called the SDN controller. Okay, so there's already the keyword there, SDN controller. To put it short, it's through the SDN controller now that all of the configurations, the routing, the fault management would be done. And once it has already been performed in the controller, it's now the role of the SDN controller to propagate the necessary configurations down to your network switches. So in other words, you don't need to go to the individual network switches to do troubleshooting more. Okay? All you have to do is to go into your SDN controller and do the configurations there. Okay? Another advantage of having an SDN controller is that if there would be any given faults within your network, immediately the controller can identify which network element or which network device is impacted. And from there, again, intelligently configure the next possible route and propagate it towards the connected network devices underneath. Okay. So there's already the split between network and forwarding. The network control would be enabled through a single entity called the controller, and the forwarding functions would now be just limited to your network switches. So you've actually simplified the role of the switches in an SDN environment. Okay. Now, I'll park again SDN here because I have another slide for a specific slide for it that's also related to SDN. I'll go back again to cloud computing, and whenever we talk about cloud computing and services that it offers, we also encounter this term, XaaS. Okay? This is an acronym meaning now, it can mean X as a service, it can mean anything as a service, or it can mean everything as a service. So the X here works double time because it can mean X, anything, or everything. Okay. This is just a collective term that stands for the increasing number of services a cloud provider can offer to its end users. Okay. So what are these services? No? Cloud in general, it offers three basic services depending on which part of the cloud it can offer to its end users. We are actually already using it right now, one of the cloud services. So I'll give you an example. One example of a cloud service is what's called software as a service. What does it do? Software as a service enables its end users to use applications without installing anything in their computer or their device. In other words, if say the end user needs a word processor, all it has or all they have to do is to go to the cloud provider's website or platform, log in, click on the Word document application, and boom, you have your Word application. If they need a presentation file or a presentation application, all they have to do is to log in to the cloud provider's user interface or website. Okay, click on the presentation application, and boom, you have presentation application. Sounds familiar, right? So you might think that these are software as a service. We're already using it right now. I mean, literally right now as we speak. I'm actually using Google Slides. No? Google Slides, Google Docs, actually the entire G Suite platform of Google. This is an example of software as a service, wherein you as the user don't need to bother installing my Word or PowerPoint or want to use spreadsheet presentation. Counting Google, your Google account, and then you have your app. That is software as a service. Another service is called platform as a service, PaaS. What does it do? Platform as a service. This is a service normally offered to developers. Okay? Developers, whenever they want to have their own environment, staging environment or dev environment, they have to again build their own computer, build their own device, set up their own network environment, isolated from production, and from there develop their application. Okay. It would take, frankly, a significant amount of time before you can even develop the application. Because most of the time, you've already concerned yourself in setting up just the environment alone. In a platform as a service, again, similar to software as a service, all I have to do is to log into my cloud provider, ask them for a platform or an environment that has the specific specifications that I need for my to develop my application, as well as all of the necessary tools, and they would provide it to me as the end user. Okay. So again, an example of this is Google. So they have what's called now the Google Cloud Platform. Okay. Wherein if you log into Google Cloud Platform, actually GCP, it's a mixture between platform as a service and infrastructure as a service. So later I'll discuss this also. When you log into GCP, no, you have there, if you need, say, a device that has an, uh, 4 cores, for instance, with 4 GB of memory, with Windows operating system already installed, okay, as well as, say, I need Java to develop my application, I can do so. I can just log into GCP and then that's it. Okay, so that's platform as a service, and that's one example. GCP. Another example, I believe this is pretty prevalent also in YouTube. No? Your web hosting providers, these are also examples of platform as a service. Okay? Squarespace is an example. Okay? Hashtag not sponsored. Okay? We also have AWS, to name a few. Okay? Now, what makes platform as a service different from infrastructure as a service is that in infrastructure, you are essentially, as the cloud provider, offering your customers hardware. Okay? But offering them in a sense that you're not selling them the hardware for them to do it on their own normally. All you have to do is to go to your hardware store. It's not the same thing. The difference in infra as a service for IaaS is that yes, you would be provisioned with hardware peripherals that you need, okay, but it is the goal of the cloud provider, okay, to maintain the operations of your provisioned infrastructure. So an example here would be, say you are an end user and you want a virtual machine that requires X number of cores, okay, and you don't necessarily need the cloud operator to install it with an operating system because you have your own, okay, and it's I can just do the configuration as needed. I don't need the cloud provider to do the configuration. So that infrastructure actions. Basically, the cloud provider will just provision you resources and through a series of agreements, no, give you enough leg room to do whatever you want with your hardware. Okay? So that's different from platform as a service, where in platform there's also a bit of software in play. Okay? If you need in platform as a service, say, if you need an environment that has these applications installed to be used for your development in creating a program, no, you can ask your cloud provider to install it. Okay? Unlike in infrastructure as a service, no, the hardware is what's being offered. Okay, so there. Now let's discuss SDN a bit. No? So I've tackled it here. Now let's discuss here also what is SDN. Now, some terminologies that you would encounter whenever we talk about software-defined networking are these: open flow, open stack, open data. Um, Despite the openness that you have right now, no, here the 3 terms. No? These are actually 3 different technologies. The first impression whenever we talk about open, what's the difference between open flow, open stack, and open daylight? No, is open flow an application? Is it a process? No, so let's set things straight here. Open flow is actually the first standard protocol used for SDN. So open flow is a protocol. Okay, this is one of the several protocols that you implement inside your SDN controller. And one thing great about OpenFlow is that it is open source. In other words, it can be developed. Okay, it allows direct access to and manipulation of forwarding of network devices such as routers and switches, both physical and virtual. So OpenFlow as a protocol has the capability to route configurations to both physical switches and heck, even virtual switches. Okay? So OpenFlow is a protocol. What is OpenStack? OpenStack, this is actually somewhat not related to SDN per se, but this is more related to cloud computing. Okay? Think of OpenStack as the Windows of your cloud, okay, or of your Linux of your cloud. Why do I say that? OpenStack is a cloud operating system. Okay. Remember the cloud services that we have here. We can implement these services or characteristics through the use of a cloud operating system, an example of which is OpenStack. It allows the configuration of large pools of compute, storage, networking resources within a data center. In other words, if I have 10 servers, 10 storage nodes, 10 network switches, okay, and I install OpenStack, okay, in one of the servers, okay, that would serve as my controller. Okay. That OpenStack operating system can consolidate all of my resources and offer them as one large entity, as one large pool. Yes, you would still have 10 servers. Yes, you would still have 10 server farms and 10 switches, no? But they are already treated as one large resource or one large cloud. Okay. In other words, for you to have a cloud environment nowadays, no, you need to install what's called a cloud operating system across your devices. And that cloud operating system, an example of which is Open. Okay, stay with me. Now, last one, Open Daylight. Open Daylight, this is a controller infrastructure used to implement SDN. Think of Open Daylight being the sister of OpenStack. Sister because you can use Open Daylight to implement SDN, okay, without purchasing an SDN platform altogether. Remember that in SDN, you need a controller. The controller is a separate entity on its own from the switches. For you to function or for you to have the controller, you need to install an SDN platform for it. So that is Open. So OpenFlow is a protocol, OpenStack is a cloud operating system, and Open Daylight is an SDN controller that, in essence, so you can actually install this inside OpenStack as a separate module or application. All of these are actually, in fact, in the underlying infrastructure layer. Okay. So we've discussed a lot about virtualization, cloud computing, and yet what we talk about NFV, all of these can in fact be found in your infrastructure. Okay. So just one quick question, sir, would you like to clarify when we say forwarding layers in SDN, are these the infrastructure layer? Yes, in fact, no. This is actually the infrastructure layer, the transport aspect of the infrastructure or the networking aspect of the infrastructure. Okay, I'll go into detail once we discuss the NFV architecture later. Okay, now NFV, Network Functions Virtualization. What is it? No? The goal of NFV is to virtualize network services, okay, that are carried out by proprietary dedicated hardware. The goal of NFV is to decouple network functions from dedicated hardware. Okay. In an ideal scenario, no, it's possible for us through NFV to purchase hardware from Dell and then deploy a core from Nokia and have it interwork with another core network element from Huawei or Ericsson. Okay, but all of them are running on the same hardware. Then that is it. Okay. Now, in virtualization, okay, you create virtual machines. In NFV, you create what's called virtual network functions. Remember in my first slide here that an application or network element, okay, when you deploy it in an NFV environment, it becomes a virtualized version. That's why you'll notice in the name there you have here a small v, connoting that this is a virtual deployment. Or the technical term for this is a virtual network function. Okay? These are the network elements that you deploy in your network, such as um, HSS. In some more recent studies, I believe there's also a push for the virtual LAN, among others. No? And finally, last term that you would encounter in NFV is what's called orchestration. Again, I'll go back to my first slide here. You'll notice that in an NFV component, you have a centralized means of monitoring, provisioning, and configuring everything in your environment. The process that's being done inside here, it's now what's called orchestration. Orchestration as in a symphony, wherein in an orchestra, you have the conductor, okay? And the conductor, it's the role of, it's their role to say when do we need to play the strings, when do we need to play the bass, when do we need to play the drums. So it oversees all of the underlying components of it in order to create the piece, the musical piece, right? This is the similar concept here, but instead of playing music, we are actually offering services or playing network services. Okay? So, just to simplify the discussion that I have a while ago, open daylight, open flow, and open stack. We can actually combine all of them in just one terminology altogether or in one system. If we're going to compare a cloud to say your computer, they're actually the same thing. No? The difference here is just the size of scale. Okay? In your computer, you have your hardware, right? You cannot have a computer without an operating system. You need to install the OS on top. And for the computer to be useful to you as the end user, you need to have software or applications installed. And inside those applications, of course, underlying beneath it is what's called services and protocols. Sorry, the text here has a bit mixed up. So inside the applications, it has services and protocols. This is how a computer system, in a logical perspective, can be seen. If we're going to scale it in a cloud environment, okay, the computer system is no longer just limited to just one system alone. We're now using what's called commercial off-the-shelf appliances or hardware. Servers. For you to manage X number of servers, you need to have, again, an operating system. This is where the cloud operating system or cloud management platform would come in. And if you want to have an application inside your cloud operating system to give out a service, you need, again, an SDN example. In this example, no, the SDN controller software where your Open Daylight is. And of course, if you want to have the specific service in a large-scale environment, you need to have your protocol. So you'll notice the three terms that I've discussed here are also present here. Open stack, open daylight, open flow. Okay? You can actually just summarize If you want a bit of wordplay and you want to include all of the three terms in just one sentence, no? OpenStack can support open data platform, which can run the open flow protocol, right? It took us several meetings, no, here in the office, here in the group, just to derive that basic understanding here in NFV. Okay, so there. Now, I'll now discuss NFV. No? This is the high level chop it into smaller portions. Okay? We can split it into four domains. Okay? Now, I think I only have 8 minutes here left, so I'll just briefly discuss what NFV is. Okay? Now, why did I split it this way? Think of the components beneath or under would be the platform. Okay. On top, this is your services. So below is the platform. On top is the services. The ones that are in the left, these are your resources. The ones that are on the right is your orchestration. Okay. We can further simplify this architecture this way. Okay. So platform, what's below, what's above are the services, what's on your left are the resources, what's on your right is orchestration or management. Okay, so the NFV platform, this is where the infrastructure lies. All of the topics that I have discussed a while ago, open flow, open daylight, open stack, okay, virtualization, cloud computing, all of them can be found in this domain of your NFV, the NFV platform. This includes the infra itself as well as its managers. You'll notice that on the right, orchestration, management, this is where OpenStack would come in. This is where your SDN controller would come in. Okay? Because these are in an NFV architecture, the managers of your resources. Okay? So the collective term for all of the components inside the management of your infra is called VIM, Virtual Infrastructure Manager. Okay, you'll notice here, no, in the standard architecture, the virtualized infrastructure management is just one block, but it can actually be broken down into several blocks, depending on which resource it manages. Okay, now this is the platform manager, the platform resource on the left. It's what's called the NFVI, the Network Functions NFV infrastructure. Okay? It also has smaller components, but to simplify this, this is where your virtualization would come in. This is where the VMs are created. Okay? This is where the switches of your SDN controller would, would reside. Okay? So in SDN, remember that in SDN you have your controller, you also have your forwarding switches. Lay it flat in the NFV environment and turn it to its side. This is the controller, these are the switches. A while ago, I showed SDN architecture this way, horizontal. Okay? Lay it to its side. That is NFV, or that is how it plays in your NFV environment. Okay? Now, all of the resources here, this is what's called an NFV chain. This includes the infrastructure resources as well as the services on top, the VNFs. Okay, now speaking of VNFs, the virtual network functions, no? This is the domain where all of the core network elements would reside, but it would now be hosted deployed as standalone appliance-based deployments, they can now be deployed as virtual network functions. We create a VNF by clustering together virtual machines for it to perform a common function. That's what's called a VNF. Are the ones that you can normally find in your telco networks, such as APIs, HLRs, HSS, among others. So in uh, almost all network elements can be virtualized. All of the things that are managing your resources, it's now what's called management and network orchestration. It automates the entire NFV life cycle. This is responsible for orchestrating the orchestrator. This is responsible for network functions are being managed by its own manager, the VN, same physical location, and then we're possible for the resources to be shared across different data centers. In an ideal scenario, you have a firewall hosting, say, or server. Now, where are we right now in the industry? Where right now, remember that I said about there is per limitation based on the current technology that we have. Um, Essentially, well, actually, no, this graph, no, this was shown somewhere around 2017, 2015. Back then, no, we're just limited to only up to 10 gigabytes of. In other words, if the network element can support 10 gigabytes, okay, it can be virtualized. This is what's called safe use cases for NFV. But due to the recent technologies that we have right now, we're even already entering also the age of containerization. We have already jumped that threshold. Nowadays, it's now possible for us to deploy NFV use cases that go beyond 100 gigabytes. 300 gigabytes, 400 gigabytes is already possible for us. Okay. The difference between NFV and an IT-based virtualization environment is that in NFV, there's also a requirement for us for throughput and latency. Telcos need to ensure that its subscribers have consistent internet. It has throughput that it would be needed by its end user. So we need also to concern here lag time delays. So that's why when compared to say IT, NFV has a bit of a smaller use case. But again, recently we've already jumped this requirement. We've already went beyond that and okay. So just to summarize, it's actually my last slide. No, just to summarize, NFV on its own, as a whole, this is a telco-based technology, network function virtualization, that uses other supporting technologies for us to implement network elements in a different approach. Through NFV, it's possible for network operators to have more leveraging power in deploying their services. In other words, through NFV, it's possible for telcos to have more flexibility in offering their services. They're not just limited to a certain service installed